Ever baked brownies and run out of chocolate? In chemistry, we call that the limiting reagent, the thing that runs out first and stops the reaction in its tracks. Whether you're doing GCSE or A Level right now, I know so many students really struggle with this. So in this video, we'll break down exactly what limiting reagents are, and I'm going to show you exactly how to calculate them simply and step by step. If this video helps you finally get limiting reagents, then give it a like and subscribe for more clear chemistry. So let's start with why you might want to work with limiting reagents in the first place. What's wrong with just a standard reacting mass calculation, for example? Well, the truth is that we don't live in a perfect world, and you're very unlikely to put together the exact amount of two reactants that you need. Usually what happens in reality is you've put in not enough of one and too much of another, so you have something left over. And that's what we're working out here really. Which one did you put in that completely reacted, and which one do you have some left over with? Now let's use an example of a pen to begin with to really get this into our heads. I'm going to really build this up step by step for you because it's one of the calculations that a lot of students struggle with. So let's work with one body and one cap making one pen. That is the same as saying it's a 1-to-1 ratio. One body, one cap makes one pen. So in this example, you can see that we have 3 bodies but 5 caps. That means we can make 3 complete pens. We therefore have no pen bodies left over. That's a limiting reagent. If we had more of them, we could make more pens. We used 3 caps in order to make the pens, but I've got 2 left over. So that is what we call our reagent or reactant that is in excess. Now let's look at a different ratio. So in this example, for a complete pen, we need 1 body but 2 pen lids. So that's the same as a 1-to-2 ratio. 1 body, 2 pen lids makes a complete pen. Looking at this example, we have 3 pen bodies, but only 4 caps. So how many complete pens can we make? Well, we can use 2 of them on one body, another 2 of the lids on the other body. That means I can make 2 complete pens, but I have 1 body left over. So therefore, the pen body, that is the one that is in excess, I have too much of. The caps, the pen lids, that's our limiting reagent, because if we had more of them, we could make more complete pens. Hopefully that's helped us get to grips with it just a little bit, and now I'm going to show you how this relates to moles. Okay, so starting with reacting ratio. So here, magnesium and bromine, neither of them have big numbers in front of them. So that means they are reacting in the ratio 1-to-1. Now let's look at the start number of moles. So we're told that we have 10 moles of the magnesium and 6 moles of the bromine. Let's start with the ratio here with the magnesium. So if 10 moles of that magnesium were to react, then 10 moles of the bromine would react with that. That's 1-to-1. But we don't have 10 moles, we only have 6. And you can't magic up 4 moles out of thin air. So that doesn't work. Instead, let's start with this 6 moles of bromine. That will react with 6 moles of magnesium because 1-to-1 is the same as 6-to-6. So that now works because we've got 10 moles of the magnesium and 6 of it can react. That means we have 4 moles left over, and that means that the magnesium is in excess. We had 6 moles of the bromine to start and 6 moles reacted, so there is nothing there left over. So that means bromine is the limiting reagent. No more of this reaction can happen because we've run out of bromine. So now let's look at the next reaction. So here we have oxygen and hydrogen, and that oxygen has no big number in front of it, so there is just 1 of it. And the hydrogen has a big 2 in front of it. So that means the ratio of oxygen to hydrogen is 1-to-2. So this is the same as that example with the pens, where we had 1 pen body needing 2 pen caps. So let's look at now our start number of moles. We're starting with 10 moles of the oxygen and 16 moles of the hydrogen. Now we have to get these numbers in this 1:2 ratio. So let's try reacting the 10 moles of the oxygen. Now 1:2 means we times this by 2, and therefore 20 moles of the hydrogen would react. That doesn't work because we don't have 20 moles, we only have 16, and you can't magic up again that extra amount. So instead, let's start with this 16 hydrogen moles and now apply the ratio this way round. So we're going to divide that by 2 to get it to fit this ratio. That means 8 moles of the oxygen will react. That works because we had 10 moles and 8 of it will react, so 2 are left over. Because we have leftover oxygen, that means this reagent is in excess. We had 16 moles of the hydrogen, all of that has reacted, so there is none left over, and that means the hydrogen, in this case, is the limiting reagent. So we're now going to add on the next skill. We're going to start the same by working out the reagent in excess and the limiting reagent. But now we're going to use that to work out the moles of product formed. Let's start out with the ratio here between the calcium oxide and water. There's no numbers, big numbers there in front of either of them. So that means that ratio is 1:1. Okay, so in this first example, we're starting off with 2 moles and 3 moles. We have to make these numbers fit this 1:1 ratio. So 2 moles of the calcium oxide will react with 2 moles of the water. Now, I didn't have 2 moles of the water, I had 3, so I have 1 left over. That means I had too much of it, and it's the one in excess. The calcium oxide, I had 2 moles and 2 moles reacted, nothing's left over. That's our limiting reagent. Now, here's your key bit. You're now going to use the moles of the limiting reagent to work out the moles of the product. If we look at this product, there's no number in front of it, so therefore it fits into the ratio as 1 as well. So the moles of calcium oxide were 2. This is a 1:1 ratio, so that means 2 moles of the calcium hydroxide is made. For the next example, let's start off with the moles of calcium oxide. So if I have 10 moles to begin with, in order to fit that 1:1 ratio, 10 moles of the water must react. Now that doesn't work because I don't have 10 moles, I only have 8 moles. And I can't get any extra. So now let's work the ratio in the other way around. So 8 moles of the water will react with 8 moles of the calcium oxide. I have too much calcium oxide, so that is my reagent in excess. All of the water's used up, that's our limiting reagent. Now let's do the moles of the limiting reagent to work out the moles of the product. The water to calcium hydroxide are in a 1:1 ratio. So 8 moles of the water will make 8 moles of the calcium hydroxide. And then for this final one, 0.40 moles of calcium oxide will react with 0.40 moles of the water. And that works because I've got too much water there. That is therefore in excess. The 0.4 moles of calcium oxide completely reacted. That's our limiting reagent. We're going to use the ratio between the calcium oxide, our limiting reagent, and calcium hydroxide. And that is 1:1. So that's going to make 0.40 moles of the calcium hydroxide. Let's look at the ratio here first. So we have a big 2 in front of the calcium, no number in front of the oxygen, so that ratio is 2:1. Now let's look at our numbers here. So we are starting off with 2 moles of calcium and 2 moles of oxygen. If I apply that ratio, 2 moles of the calcium will react with 1 mole of the oxygen. Now, we had 2 moles and only 1 has reacted. So we have 1 left over and the oxygen is therefore in excess. That makes the calcium the limiting reagent. In order to work out the moles of the calcium oxide, again, let's look at the big number here. That's a 2. So the easiest way to now do this and work it out is to use the moles of the limiting reagent, because that's how much actually reacted. Half of that oxygen sat there and did nothing. So if we look at the ratio of calcium to calcium oxide, it's 2 to 2. So therefore 2 moles of the calcium react to make 2 moles of the calcium oxide. Okay, next one. So here we now have 10 moles of the calcium, 2 moles of the oxygen. If we apply the 2 to 1 ratio, we either have 10 moles of calcium will react with 5 moles of the oxygen. But we don't have 5 moles, we only have 2 moles. So instead, let's work the ratio the other way around. So 2 moles of the oxygen will react with 4 moles of the calcium. Because we had 10, only 4 reacted, 6 are left over. That makes the calcium in excess. We had 2 moles of the oxygen. All of that has reacted. That makes it our limiting reagent. We're going to use the moles of the limiting reagent to work out the moles of product. Let's look at the ratio. Oxygen to calcium oxide is 1 to 2. So 2 moles of oxygen will react with 4 moles of calcium oxide. And the final example here. So we're now starting with 0.5 moles of calcium and 0.2 moles of oxygen. Let's work with the ratio. So if I took the 0.5 moles of calcium, then that would react with 0.25 moles of oxygen. That's too much. We do not have that amount. We only have 0.2. So that can't work. So instead, let's work with the oxygen. 0.2 moles of the oxygen will react with 0.4 moles of the calcium. We had 0.5. 0.4 reacted. We have some left over, and therefore this reagent, the calcium, is in excess. The oxygen, we had 0.2 moles. All of that reacted. It's our limiting reagent. Now let's use this limiting reagent to work out the moles of product. It's a 1 to 2 ratio of oxygen to calcium oxide, and therefore 0.2 reacts to make 0.40 moles of the calcium oxide. Now I'm going to teach this the same way as I do reacting mass calculations. So if that is new to you or you can't remember, head back to the previous video and I'll talk you through this method from scratch. So the way that we always start these calculations is to determine our tick and question mark. Now our tick are the substances in the equation that we know something about. Let's add those now. So the tungsten oxide, we know that we have 23.2 grams of it. For the hydrogen, we also know that we have 20 grams of it. Now this is immediately how you spot a limiting reagent calculation. If they don't tell you, you will have 2 ticks. A normal reacting mass calculation will only have 1. The question is also asking us what mass of tungsten is made. Tungsten is W. You can always check that on the periodic table if you're not sure. Because the question is asking about that, that is our question mark. So we always start with our ticks. I'm going to work down each column now. So I'm going to work out the MR of the tungsten oxide next. I'm going to look on the periodic table and the AR of tungsten is 184. I'm going to add that to 3 lots of oxygen, 3 lots of 16. So 184 plus 3 times 16 is 232. In order to work out the moles, then we do mass divided by MR is equal to moles. So 23.2 divided by 232 is 0.1. Now let's work down the next column. So I know I have 20 grams of the hydrogen. The AR of the hydrogen is 1 and it's H2. So 2 lots of 1 means that MR of hydrogen is 2. 20 divided by 2 is 10. Now we have our two amounts of moles. We're going to use the same skill as we were practicing before. So we're going to look at the ratio here, the big numbers in front of the tungsten oxide and hydrogen. These are reacting in a 1:3 ratio. So if I take the 0.1 and times it by 3, then I get 0.3 moles. That works because I had 10 moles of it. That means I've got loads left over. Only 0.3 moles is going to react. This is therefore our reagent that is in excess. For the tungsten oxide, we had 0.1 moles and all of that reacted. That makes this our limiting reagent. In order to do the next step of our calculation, we now use the moles of the limiting reagent always. We're looking at the ratio between the tungsten oxide, our limiting reagent, and our tungsten, our question mark. That is a 1:1 ratio. See that? No big numbers in front of either of them. So therefore 0.1 moles of tungsten oxide will react with 0.1 moles of tungsten. Now we're working up the column. So the AR of the tungsten, again, check your periodic table, is 184. In order to calculate the mass, last step, we do MR times moles is equal to the mass, and that gives us 18.4 grams. Not forgetting the units for our overall answer. There we go. Here's our final bit of practice for today. Make sure you hit pause if you want to have a go before we go through it together. Let's start the same with our tick and question mark. So we are asked about what mass of sodium fluoride is formed. The sodium fluoride is NaF, that is therefore our question mark. We're asked to find something out about it. For the sodium, we know that we have 2.30 grams. We also know something about the fluorine. We know we have 2.85 grams. And again, compared to any other calculation, you know this is limiting reagents because you have 2 ticks. That means we now have to work down both columns. So the AR of the sodium off the periodic table is 23. Remember, it's always 23. You ignore any big number at this stage. And for the fluorine, we have the AR of 19, but it's F2, so 2 19s are 38. In order to work out our moles, we do mass divided M by MR equals moles. So if you pop that into your calculator, 2.30 divided by 23 is 0.1. And 2.85 divided by 38 is 0.075. Now we need to work with our ratios and work out which is the limiting reagent. So we look at the big numbers in front of the sodium and the fluorine, and it's a 2:1 ratio. So if we apply that ratio across, then 0.1 moles of sodium will react with 0.05 moles of fluorine. And that works because not only do I have 0.05 moles, I have too much. I have 0.075. That means I've got some left over, so my fluorine is the reagent that is in excess. We don't have any sodium left over, however. All of those 0.1 moles reacted. It's our limiting reagent. Now we use the moles of limiting reagent to work out the moles of our question mark. Look at the big numbers again. Between the sodium and sodium fluoride, it's a 2:2 ratio. That's the same as 1:1. So 0.1 moles of the sodium will make 0.1 moles of the fluorine. Now we work up the column to find our final answer. So the sodium fluoride MR, we do the 23 for the sodium plus the 19 for the fluorine, and that gives us 42 as our MR. We do our MR times our moles to equal our mass, and that gives us 4.2. If you are A-level, you need to think about significant figures. And both of our bits of data to begin with were 3 sig figs. So the answer is 4.20 grams with the units as our final answer. Thanks for watching, and if this was helpful, hit like and subscribe now. For more new GCSE and A-Level Chemistry videos every single week, let's get you through this exam together.